fluorescent light. Now, I could have actually done this using a simple cigarette lighter or maybe another matchbox. But when you have some flexibility of electrical energy with you, you can actually do all these things. Now, this should also all be done within the safety precautions to avoid an electric shock, however. So let's talk about electricity and electric shock today. Welcome to AV Tech Space. Now, we did all these things, but still we didn't get an electric shock. That is despite of the fact that as per the specifications, there is 4000 volts of electricity between these two lines, voltage between these two lines. And partly because of the reason being I'm having a wooden matchstick, and also the current will flow in between these lines. So there is no chance that we are actually going to get a shock here. But when you talk about electric shock, what actually matters is the amount of electricity that is actually flowing through the body, not exactly voltage. The current actually what is mattering here. Let's prove this using a small experiment. Now this is our experiment, our simple small experiment, just to prove it. Now what we can have here is a simple 230 volt supply, which the same wire we have actually taken in. What I've done is I've just broken the wire connection in between and exposed the part of it, the copper. And a small change what I've actually done is I've taken a small neon lamp and a resistor and connected in series over here. This is actually nothing, it's just a modified circuit, whatever it's present in a regular tester, what we can actually find. Now the point is, this broken circuit, if I complete it, this bulb should glow, and I'm going to complete it using my hand so that the electricity would flow through my hand so as to actually complete it. It should be safe if our calculations are right. Now the first important lesson is always remember that this is a reversible connector. The stupidity what I had actually done is I had actually connected it over there and reversed it so that the phase came over here and rather than here. So the problem is the connection what you do for the resistor and the plug should be on the phase, not on the neutral. Very important lesson, I just learned it. So now what I've done is I've just reversed this connection over here, and I'm just gonna connect using my fingers over here, and it should glow if everything is right. Yeah, it does glow. I've just connected using my fingers here, and it glows. So what do we understand here? So the idea is that the amount of current, if it is actually sufficiently low, it is safe even if it flows through our body. So here the amount of current is so low, it is perfectly safe. Now with all this experiment what we have actually done on a 230 volt supply, we didn't get a shock. It has to do with the amount of electricity that actually passed through my body. It was pretty low. Now if I do a rough calculation of this with the amount of resistance over here, I can see that it was roughly only around 200 microamperes of current. Perfectly safe. So if we look at the standard limits of the current, if we can actually understand that around 6 milliamperes of current, if it passes through your body, it's almost like safe. You will not even feel it. 6 milliamperes is roughly amount of the current which is drawn by a charger of an old phone. Now these amounts of electricity what I'm actually mentioning is just statistically average on a typical human being. It can actually vary depending upon your thickness of your skin, your body nature, and your climate even. So it's only an average. Now if the current actually crosses across a certain limit, then like roughly around 20 to 22 milliamperes, things start to make a change. You will not be able to let go of the conductor which is giving you the electricity. This limit is called the let go limit. So in this, after crossing this limit, what happens is that it starts influencing the muscles of your body. Now you have extensor muscles and flexor muscles on your body. The flexors let you grab something and extensors let you release it. And once this limit actually crosses, once current actually crosses a particular limit, the signals from your brain cannot be doing this action what is intended to do on your muscles. It cannot it cannot release the conductor, whatever it is there. And moreover, in addition, your flexor muscles being stronger is always overpowering the other extensor muscles. So you'll not be able to let go of this, and more current thereby flows through your body and can get you killed. So this is something which has to be, this is very important. Now, some people actually recommend that you do not hold the conductor like this in the open arm position. Take it always on the other side. What happens is, even if there is actually a grabbing action which actually comes, it will not grab hold of the conductor. Rather than it will actually let you release it. So this is actually safer. But still, I personally would not recommend it. I would say that you still use the tester, ensure that there is no current, and then only do any sorts of maintenance activities on these power lines. Safer is to switch off your main supply and then only do any of the activities. So that's all for today. Hope this video actually made you understand electricity a little more and your life a more safer. So if you liked it, enjoyed it, please like, share and subscribe. Thanks for watching.